Okay, so I just wanted to show you over a series of images how it changed. This one was set to 80 degrees Celsius. Uh, so at that point, the electric field is no longer the dominant force. It's just kind of brute heat. But you can see the difference in this rather quickly just looking at some images I took without saving a whole bunch of video, which takes up a lot of space. So here's the experiment on the left. On the right is the control. Here's the temperature control because I wanted to have the thermometer sensor for this in a similar dish, but that's just water. So, but as you can see in the beginning, basically the same, max and min, and then the average is, you can't see it here, but the average is all the pixels in here. So as you can see, heat comes on. The color almost doesn't matter. It changes just in relation, but you can start to see the difference in the sizes, how it starts to shrink. And here you can see, so here now it's higher temperature. The experiment is now a higher temperature than the control because the control is still evaporating. And it's not perfect because, as you can see, there are times when the paste, it will shrink to where then you end up with some hot spots. But it's still a pretty good illustration of how you can use these off-the-shelf technologies for evaporation enhancement, especially in a small bootstrapping type laboratory situation. And so here the control, it's clearly still evaporating. But then here we can see it's just about done, maybe not quite, but that's the last image I took. So we can go back through it just so you can kind of see the progression. And I'll go back again. So it just adds another dimension to the analysis, and then we get graphical data from all these data points per second. So it's just a useful tool.